All right then. Cool. I think we are live and the connection looks stable almost. One sec. Hello. I'm sorry. Yeah. Okay, let's go. So I marked all these, all that we covered. So brings up to about 90 questions. So most of what we've encountered right now is arrays, some of bitmap, uh, bit manipulation, some hash maps, some back backtracking, very little logic, no trees, I think yet, or even linked lists, I think. Okay, some sorting as well. Okay, uh, it adds spiral matrix too. So spiral matrix was like a design like this. You can want to generate a square matrix filled with the elements 1 to n square spiral order. Hmm. One sec. Okay. Yeah, so fair enough. We do the same thing that we did in spiral matrix. In spiral matrix, we were iterating like this, and we were pushing in an array. Let's just copy this code. And at that item, we do this. Now we'll have to generate this before the for loop. Have to generate this now. So m equals n make a matrix of size n times n. Let's call it matrix. Uh, vector int size n, vector int. Let's make a temp of size n, and then make this as temp, and then do this. And you have to do this for every loop, and then set this as well, but different variable instead. So here it's u, here it is going to be row, here it's d. Actually, I'm not sure why I'm even doing this question. This is totally not worth it. Speed plus plus. We're just rewriting the code in a different way. So this will probably not be right, but you get the point. We're just going to be doing the same iterations, and we'll be setting. So let's set the matrix in a n square loop before this, and then we'll just set the value. So doing this. For int x equal to 0, x is less than n, x plus plus. For int y equals 0, y is less than n, y plus plus. Sorry, I don't even need an n square, just need n. So vector int temp matrix x equals temp. That's all. So now I'm just going to be putting values at those indices. Reference binding to null type. size here. So where is P? P put set P as 1 and we submit. Awesome. Really actually shouldn't have done it all together. Okay. I think there's a notification about a contest maybe. Yeah, maybe we'll see. I don't know if I'll get up that early. It's 8 in the morning. Given a set contains a total number of n factorial unique permutations, right? By listing and labeling all the permutations in order, we get the following sequence. For n is 3, given n and k, return the kth permutation. Hmm. Okay, so I think I might know this answer. I've not done it, I've not coded it before, but I do have some memory of something similar to this. So basically, this is sort of considering your subspace. uh, Sort of looking it in the DP style of things. So you're given K, right? Okay, so um, what are the permutations of, you know, 1 to n? So first you have n minus 1, n minus 1 permutations that start with 1, right? Because, so say if you keep 1 here, sorry, n minus, yeah, n minus 1 factorial permutations. Because if you keep the first, keep 1 in the first place, then you can keep n minus 1 numbers after it, then n minus 2, then n minus 3, and so on till 1. So you get a total of n minus 1 factorial numbers like that. Similarly, when you keep 2, you get another n minus 1 factorial numbers, and so on and so forth till n, which also has n minus 1 factorial numbers. So the sum becomes n into n minus 1 factorial, which is n factorial, which is what it is. So given n and k, return the kth permutation sequence. So you don't need to calculate all the permutations before the kth permutation, but for the kth permutation, what you can know, so you're given the number k, right? So k is going to be represented as, so how many permutations are you going to have before the kth permutation? Um, so if the total permutations are n into n minus 1 into n minus 2 and so on. Um, so let's take an example. So let's say in the case of 1, 2, 3, we want the fourth permutation, which is 2, 3, 1. So we've had n minus 1 what is n? N is 3. So we've had n minus 1 factorial combinations of 1 before it, which is 2 factorial, which is 2. And we have, then then we have 2, and then we have two options of n minus 1 into n minus 2, uh, where since so basically this is the second one in that. So for when k was 4, um, k was somewhere between 1 and n factorial. So so for 3 it was 1, 2, 3, 4, 5, 6. So k was between 1 and 6. So now let's say, was it between 1 and n minus 1 factorial? If it was, then we already know the first number, don't we? It's 1, because what uh, that is what is covering the first n minus 1 cases, all the numbers starting with 1, n minus 1 factorial, 1 to n minus 1 factorial cases. So is our k between 1 and 2 factorial? No. Is it between twice of 1 and 2 factorial? Yes. Is it between 2 and 4? Yes. Included? Yes. It's at the fourth position. So basically, we set our first digit to reduce our answer subspace to n minus 1 factorial. But to do that itself, if the first element is n, if it's in the last set, say, then we have to do n iterations. So, and then reducing for every number, we'll be doing n factorial calculations itself. So maybe that's not the best option then. But we still have to figure out a way of finding what set k belongs to. Now k is already between x times 1 and n minus 1 factorial, right? But we can't sit and calculate n factorial. Or can we? So say we have the number n factorial at least. So how many loops is that? That's on, right? So I don't think that is a lot. So I think we can calculate n factorial. Int n fac is 1. If n equals 1, return 1. Um, for I equals 0, I is less than n, equal to n, I plus plus, I is equal to 1 to n fac equals n fac times I, right? You can start with 2. We already covered n1. So n factorial has been calculated. Now we actually only need to calculate n minus 1 factorial. So let's keep a track of the last factorial number that we calculated. So let's say it was n minus 1. Um, Now to find um, So now k will be between 1 and n fact, right? But it will be x times that number. X could be 1, it could be 2, it could be 3. So so while let's say we want to go until the last permutation that we're checking for is not the last number, and let this be our return value, and let this be our selection. So while, and let this be some sort of counter that we have for x. Let's say this is the x that we had, where k is x times some number between 1 to n1. So let's say x is 1. So I think x and p are the same thing. That's okay. Um, so while k is less than x times n fact, basically when it's in the range of this, and k is greater than equal to um if it's less, then we keep increasing our set. If we increase, so basically we move x forward. So when we finally get to a stage where it is not less, means we're in the in our answer set. So then it means that we can push p, and we can do p plus plus, and we do this while x, sorry, now x becomes 1 at the start of every loop, at the end, wherever you like, and we do this while ret dot size is not equal to n, and then we return ret. So basically, let me iterate through this and show you what's happening. So we check, okay, we have to reduce k as well, because k was between 2 and we have to reduce n fac actually. So n fac equals n fac divided by last and last minus minus. No, because no, actually, so we found x, right? Uh, so it means the number is between x and x times n minus 1 factorial. K is between this, right? So now you reduce the space by searching for the number. Searching for which number? Um, I have n minus 1 numbers left, where n minus 2 cases for one and n minus 2 cases for the other. So what is our k? K was the, say you have to find the fourth number. So what did you find? Was k what? So it was between x and x minus x and n minus 1 factorial. Now you have to find, so say it was between 2 and 4, yeah. Now I have to find a subset under this. So a subset under this from x times 1 to n minus 1 factorial is 1 to n minus 2 factorial, um, then n minus 2 factorial to twice of n minus 2 factorial, and so on and so forth. So yeah, so what this will do is it will reduce our n factorial number from x of n factorial to all the smaller subcases. And when we hit the subset, we will know that we will know which character to push actually. So for the first character, it's 1. Oh, so it's not going to be 1 actually. It's going to be based on which set it is in. So if it's in the first set plus x minus 1. That's what is it's going to be. And we don't need to update p. Okay. What is n will be, oh, which is 1 and 9. So that's okay. Mm, while last is greater than 0. Let's see how that works out. So your output was 2. What? Okay, let's just debug this. Pretty curious if this logic is right. So n was 3, last became 2. So n fac was 2, right? So x was 1. So, oh sorry, it's not less than, it's greater than. So if it's not in this set, right? Sorry, don't need to debug. So the number of characters is less. It's 2, 3. Let's check why it's coming to be 3. So how many cases in our first section from 1 to n minus 1? Then so on and so forth. So n cases, right? Then you have to cover n minus 1 cases. So this is 1 to n minus 1. Yes, then it is 2 to n minus 1. Okay. So is 4 between 1 and 2? No. And this is 4 greater than, what is n fact? 2. What is x? 2. Is 4 greater than this? No. So basically 4 is between 2 of n minus 1 and 2 of n minus 1. So we push our character, which is x distance from 1. Then x becomes 1. Oh no, so x can't be 1. X has to be the next character. So x, okay, we'll keep x for this itself. And we'll have to keep another character, a number, which will tell what iteration we're on. So that we add that number to our list. Right? Okay. So last was 2. Now it's become 1. So we do have to divide it. Maybe we can do the last number manually. So it's not going to be x. X is just the section that we are in. Uh, if it's in the, if it's between n minus 2 to n minus 2, you know, sorry, from 1 to n minus 1. Inside there, if it's from 1 to n minus 2, or from n minus 2 to n minus 2, or from 2n minus 2 to 2n minus 3n minus 2, and so on. So the x is basically, is it first section, second section, third section? So this one is not going to do. It's going to be some iterator instead. For which character we're on. So say if x breaks at the first point, So now x breaks at the first point in the second iteration. So now it's the number based in the second, it's the number 3, not 2. Uh, so if we start x from 1, we have to keep a variable that adds. Let's keep that variable as int k equals 0 or k equals 1. So, sorry, k equals 0 plus k. We can start k as -1. And the last character we'll push manually. We can do that. Oh, sorry, int k, not k, or j. Hmm. We have too many variables and such. Not sure if it's actually right or not. Let's see. Still getting 2, 3. I have to update j also, I think after every iteration. Make it j plus plus. That makes it to 4. So we'll just debug why that is happening. Okay, so we already had a number. So this is only for case 1 to n minus 1. So say if it was n minus 1 to 2n minus 1. So then our result would be between n minus 1 and 2n minus 1. So is it n minus 1 to 2n minus 1? Hmm. Factorial, right? So is it between n minus 1 into to n minus 1 into 2n minus 1 or 3 m, say like 2 factorial, and then it's 2 factorial to n minus 1 to 3 factorial to n minus 1, so on till n minus 2 factorial to n minus 1, n minus 3 factorial into n minus 1, till n minus 2 factorial into n minus 1. So if we decrease n fac, we do need to increase something. That is the set that we were on, which was x basically. So let's keep a variable as int last x equal to 1, and then we multiply this by last x, and then we save last x as well, and then we test our code. Should be, the answer should be 213, right? Signed overflow cannot be represented in type int. What? see what's wrong with this. Is 3 greater than, nope. So we have this, we have last x as 2, the last x as 1. Oh, where do we have last x is 1? Is k greater than, ah, so the section it is in is the second section. That's okay. Hmm, hmm, hmm. What just happened? Where are we? Okay. Now x is 1, last x is also 1, and in fact is 1. Ooh. So why was it working earlier when... Oh, sorry, it's not this. It is last x is x. My bad. Yeah, so we're still getting 2, 3 for some reason. And you want 2, 1. So let's see why. ठीक है. So we already have 1 in our result. 2 in our result, okay. Now k is 3. So is k greater than the top of our last list? Think we might need n fact to be this only. And last is n. So we have 1, 3, 4. Okay, let's ignore that. But basically, we have to change our k a little bit because if n is 3 uh, and oh no, we can't. No, this k will never be greater than n factorial. Um, so you have n minus 1 options. No, you have n options. Does k lie between 0 and n minus 1? Or n minus 1 to n minus 1? To n minus 1? And so on. So this is n minus 1. Is k greater than n minus 1? If not, then x is 1, which means the first factor is 1. That's fine with us. Then we reduce this, right? Uh, but it's not in this section for us right now. It is in between n minus 1 and 2n minus 1. Now, n minus 1. So is it between, so maybe it's not x, maybe it's last x is last. What was the x? X was the factor that we had, right? So say it's between n minus 1 and 2n minus 1. So x was 2, factorial, factorial. So now we don't care about this 2. What we care about is it between n minus 1 fact n minus 2. So what is n minus 1 factorial? It's n minus 1 into n minus 2 factorial to twice of n minus 1 into n minus 2 factorial, or is it between twice of n minus 1 into n minus 2 factorial to n minus thrice of n minus 1 to n minus 2 factorial. So the number to multiply with is the last, actually, and it's actually times equal, because we are not leaving that as well. So we should get 2 1 2 3 again. Let's see what's happening. We have 2. Now last x is 2, which was our n minus 1. So for this set, our sets were 1 to n minus 1 factorial, which was 3 minus 2 factorial. So 1 to 2. Then 2 n minus 1 factorial to twice of n minus 1 factorial, which was 2 to 4. And next was 4 to thrice of n minus 1 factorial, n to n, which is 6. Now inside n minus 1 and 2 n minus 1 to n minus 1 factorial, we had n minus 1 into n minus 2 factorial to 2n minus 1, sorry, to n to 2n minus 1 to n minus 2 fact plus the whole set. Sorry, 1 of n minus 2 factorial into 2 of n minus 2 factorial. So the number we are multiplying with n fac so our limit, it's the loop goes from 1 to n minus 1, then 1 to n minus 2, and so on. But the factor is always going to be 1, 2, 3. So this is the factor, and this is the last number. But we need another factor, right? Do we not need n minus 1 here at all? No, to go from n minus 1 to n minus 2 of n minus 1 factorial, which is n minus 1 into n minus 2 factorial to 2 of n minus 1 into n minus 2 factorial, we You can't remove n minus 1. But what are the subsets of this? So you can replace. What can we replace? What's the number that comes after n minus 1 into n minus 2 factorial? So it was 1, 2, 3, 4 for something. So it has to be incremented by just 1, right? Or not. So the factor we had was n on the side because you're counting n. Here we can have the factor n minus. Can we fix n minus 1? So n minus 1. Let's take a bigger example. Let's say 4. So like n is 4. So n minus 1 into n minus 2 factorial to twice of the same. So n is 4. So it is 3 into 2 factorial to twice of 3 into 2 factorial, which is 6 to 12. So how many cases for 4 factorial? 4, 3, 12, 8, 6, 24, right? So we have 24 cases. So it's 1 to 6, 6 to 12, 12 to 18, I guess, and 18 to 24. So we are here, right? Now how do we increment this by 1? How do we check if our answer is in this set or the next set? We can only change. Okay, so let's say it's in this set, right? This was our first conclusion after we checked this. Then what is it going to be in between? So n minus 1 to n minus 2 to n minus 3 factorial to n minus 1 twice of n minus 1 to n minus 2 to n minus 3 factorial. So this is 6, 4, 3, 2, 4, 3, 2, 1, 6, and 12 again, it's saying. So no, so we have to reduce our space each time, right? Somehow. By how much do we reduce the space? So this is our space right now, 6 to 12. Why don't we reduce k? Because the number of numbers you have to find now is less. So k was the no k was the index actually, so the fourth number. So is 4 between, sorry, so for, let's say our k was 7. So is k between 1 and n minus 1? No. Is k between n minus 1 and 2n minus 1? Yes. What are all the numbers between n minus 1 and 2n minus 1? N minus 1, n, n plus 1, n plus 2, so on till 2n minus 3 and then 2n minus 2. Okay, how many numbers are these? These are like n minus 1 numbers. And how many options do we have to fill in them? N minus 1. But how many combinations do we have? We have n minus 1 factorial combinations. Uh, so we have to fill n minus 1 factorial places by n minus 1 numbers. So we have n minus 2 factorial sets. So we have to iterate through n minus 2 factorial sets n minus 1 times. So I think this is not necessary, actually, or is it? No, this actually is used to maintain k, but because we're not maintaining the count anywhere. हाँ हाँ कर गए हाँ नहीं ज़्यादा नहीं हाँ हाँ कोई ठीक है ठीक है Okay, so we did imagine the cases, but we didn't actually keep track of the number. So how do we calculate? So we have to go from 6 to 12 in the case of n being 4 and k is 7. So 6 to 12 is divided into some subsets as well. Hmm. 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 So what we can keep not as last x, what last x is actually gonna be, just I think understood. Since what we have to do is actually add, why don't we add something itself? So last x is actually x times nfac. Because you have to find from this range to the new range. So we start from this range and count smaller subsets of this range going forward. Sorry, 0. Yeah. And it becomes plus equal to. Okay, so it's 2, 2. Closer. Might be some variable that we're missing out here. So x is the set that it's in, like the first set or the second set. J is -1. Should be 2, 1 now. Oh, sorry, it's not. Okay, let's just check. One while loop. Red becomes 2. What is x? X is 1. So our question was 3, 3. So our for 3, our sets are n factorial, which means for n numbers, for each number there are n minus 1 factorial cases. So we have 2 factorial cases for each number. So 1, 1, 2, 2, and 3, 3. For k is 3. So we check our first loop is for first subset. First loop is for first subset. So is 1 times 2 plus 0 less than 3? Yes, 2 is less than 3. So we go to the second subset. Now the cap of the second subset is 2 times 2, it's 4, plus 0. So the second subset are, yeah, is it less than 3? 4 is less than 3? Nope. So we go out, we set last x as, oh, it's not n x times, in fact, it's actually the lower limit. Sorry, I don't have to debug this anyway. And now, since we have the first 2 digits, the last digit will, what? It's crazy. Uh, it's 2. So is 1 times 1 plus our last cap, which was 2 less than 3. Yes. So, sorry. So now we have 2 numbers, 1 and 3. So we have only n minus 2 sets. So is your number in the first set between whatever and 4? Yes. Then you push the first number available in your current set. Oh, so it's not about J. So it depends on what the previous number used was. Okay, one sec. Let me think about how to do that. I think maybe it's string only. Yeah, so just like just expected. For the last number, I just use this so that it's going to be like just 9 iterations at worst. I mean, depending on the size, 9 or 8 iterations. So that's okay. Most concise, minimal memory usage. Uh, so yeah, this is the string that we were keeping, and this is the yeah, this is the string that we were keeping, and then while iterating, um, reduce the number of cases, calculate the index of the character put at x. Is k used? Oh, k times f. It's the same thing in a way. This is sort of what k times f is the replica of. So what they're doing is um, moving. It's literally exactly the same thing. I don't have anything to add really. Except that they're changing these to I don't know to do something. Oh, so they're while iterating, they're moving the correct position to the top. I equal to 0 I is less than n, which is the which is my outer loop as well. The last variable. Yeah, this one. Is there any variable that's not used? I think J is not used anymore. Yeah, I can do J, I can do P as well. This is our answer. This is the last X that we've kept for checking the set. Uh, this is our factorial. This is our last variable, which is basically which was the last set that we're on. It's the n minus 1 set or so on. And yeah, I think this is a Gucci solution, guys. Hee hee. And this will actually also work for numbers above 10. This will probably give like a input invalid. Invalid input. Yeah, some weird shit. It's probably not my error, probably. Oh, yeah, it would give an error here as well. Anyway, alright, we got it. We got a great solution as well. Cool. You can look at the other solutions if you like, if they are easier for you to understand. See if it was an upvoted question or not. I think it was. Yes, good. Sorry, I think it was. Yeah, either way. Okay, this is a bad question. Being given a linked list, rotate it by k places. So probably, um, so you see if k is 2, then you have to send it here and send this here. So you just go k places to the right, and then you move till you reach the end, and then you attach this to the head and set this pointer as null. So if you are say 2, you know 1, 2 points over here, and then you move till this is at the last node. So 1, 2, you go here, and this goes from here to here. This next becomes null, and this next becomes head. And then this next is stored and returned. For example, for this one, K4, you can just do percent length. So just calculate the length in the beginning and then do percentage. So 4 means 1, 2, so length is 3, so just 1. So just moving this then. So to do that, you move 1, then you move next till that becomes, and so on and so forth. It's really simple. So uh, auto head copy is head, int length equals 0, while head while HC next is not equal to null, HC equal to HC next. We'll just write it still for the answer's sake. It's also very small. You can take care of corner cases. If head is null, return head. Then k percent equals length. So for I is 0, I is less than k, I plus plus. HC equals head. HC equals HC. Next, we moved 2 steps. Now keep another head, H2, and you move that twice. Sorry, that till HC reaches the end. Doesn't reach the end, while HC next is not equal to null. This for 2 is for 2. Sorry. Yeah. Now your new end is being pointed by at h2 dot next. So you make a new head which is h2 next, and then you mark that as null. And now your HC, the pointer at the end, has to point at the old head. Okay. Maybe some corner cases might fail where the length is too weird or something. Like maybe where e short length or k is equal to the length, maybe if say k equals length return head. What is the length? I think my length is wrong. Yeah, now it should be fine. If it does work. Ugh! Sorry. If head is null, then return head. If k equals 0, even then. Okay. Oh God. If head next is null also. If head next is null. Okay, I'll just be back. This should work unless this whole website is bullshit. It is, I guess. Okay, for length being a factor of k, I guess it's not working. So k is 10. 10% 5 is 0. Let's add that case here instead. back. Till then, you can look at the solution if you like. Okay, we are back. Anybody have any questions? They can ping in chat. I do also take up questions later. Sorry, I was saying I do also take up questions that are not related to LeetCode. Maybe you have some other questions in general. I do have a little bit of experience in JavaScript as well. So if you've got any questions on that, go right ahead. My exceptional user base. All right. Okay. Just one sec. Where was I? Okay. I did need to manage my extensions. Anyway, let's do that later. Um, Let's check the solution if there's a neater solution, let's say. I think mine has a lot of cases. No, if not, had return. This. Okay, next, get the number of nodes. Yeah, I guess that's the same. Cool. Oh, I've done this question. I've definitely done this question. I remember this image because um where have I done it? This is DP, right? Okay. So the question is there's a robot located at 0, 0 of a grid and you have to reach the finish line. And in how many ways can you reach there given that you can only move either down or right. So essentially DP comes in when you have the answer to your smallest problem and then you want to answer bigger problems. So say if you're already here, then you don't need to move at all. So the number of moves or paths is 0. When you're at this point, you can move either, you can only move to the right. So you have only one path. From this point, you can only move once. And you have one path. And if you see carefully for all the borders here, these two borders, bottom border and right border, you only have one path. That's just to go straight right. So the steps aren't really something that we're concerned with. We're only concerned with the unique possible paths. So there's one path from all of these to the right and one path from all of these to, going down. Now using this, we can calculate all of these. So you can do it in any order, right to left or bottom to top. So basically, let's say we go start with here. The number of unique paths from this point is the number of unique paths from here plus the number of unique paths from here. So because you can either go here or you can go here. So this is part of the unique paths that start from here, and this is also part of the unique paths that start from here. So the unique paths from here is sum of these two numbers. Similarly for this, it would be this and this because you can only go right or bottom. So say this becomes 2, so this becomes 3. Similarly, this becomes 4, 5, 6, 7. This becomes 1 plus 2 is 3. This becomes 3 plus 4 that we had here, 7, and so on and so forth. And this finally becomes this plus this. So you get your answer like that. So I might find this question answered already. Here, best time to buy and sell stocks. Stairs. Oh, it's this. Oh, why have I not submitted it? Oh, it's not this one. Um, Largest area of rectangle. Oh, yeah, this is a tough one. It's probably in the hard section. Longest increasing subsequence. I hate these questions. Ways to decode. So it seems like I saw the solution. I mean, I saw this question here itself and didn't really. Yeah, we don't really need to reduce space so much that we're not able to understand the solution. Let's just keep it simpler for now. Yeah, so just going from, so you can take I and M and your result will be the last index. Um, it's because rotating this, say if you start from here, say this was your finish and this was your start, you would be counting these two, I mean these borders and then this row and then this row. So it's the same thing. You start from I1 to M or M to 1. Same thing. Okay. Unique paths too. Okay. Much lesser submission rate. Oh, okay. So this is similar to what I had opened over here but never solved. I don't know what reason. So the robot is trying to move. Same answer, same question. Now consider if some obstacles are added to the grid, how many unique paths are possible in that case? So let's actually pick this solution up itself. I think there's only going to be a very small modification to this to find the answer to this one. So let's just declare m and n, m and m. Int m is grid dot size and n is grid 0 dot size, right? To declare, we have declared these already. Okay. Now, that's right. So we'll be calculating, say this, and it'll actually be 0 in case the ij for this is 1. Yeah. So if obstacle grid ij is 0, is 1, is 0, then this, else current j is 0. Now this might have some problems given I and j are going from 1 to m and this grid might be in the opposite order. But then again, I think wherever you locate the one, output 1, expected 0. Uh, yeah, you can just add some cases like say if obstacle grid 0 0 equals 1 or obstacle grid say um, m cross n is equal to 1, then we can just return 0 directly. Huh? Sorry. I think we can actually start from 0. Fair hair. Let's put some brackets in case this code gets confused. Mm, Now if I is 0, then keep current j as 1. Or if j is 0. For all other cases, I think this is fine. I hope you forgive me for my absence of brain cells. Awesome. So filling up the corners with 1 in case they're not blocked. Oh, so actually, else if obstacle I j minus 1 equals 1 and obstacle minus 1 j equals 1 else this. Hmm. God, these. Okay, so the actual answer is probably not like this. If that is, if this passes. Okay, never mind. So flag is false in case for one iteration, in case the entire row is blocked. Okay, we actually have to calculate that. Okay, what I was doing was previous j for all the columns, these the rows, I rows, the zeroth column. So if say if they're all one for this j, then this row is entirely 0, and so previous row is entirely 0, and current row, hmm, that's the problem. I guess we'll be fine now. Closer, I'd say. So first row we get oh, hmm. I just wrote this, man. How could you have blown your brains out so hard? Let's say and I is not equal to 0. Either of them 0 and both of them are not 0. Yeah, but I'm still wondering. Okay, screw this and screw everything. I think we have the answer anyway. But I just want to see why. Ah, because I'm setting. No, so this 0 is 0. This one, oh, because for the final row, I'm still setting it to 1. Okay, that's just one case that we are add here. Otherwise, it's fine, I guess. We still should just copy the code and write it down so that Yeah, there's a checkbox against the question. Awesome. Let's minimum path sum. Hmm? Oh, that was unexpected. Let's keep it long. Just cast it. Yeah, cool. Maybe there are test cases after that submission, his submission. So given a m cross n grid filled with non-negative numbers, find a path from top to bottom, top left, bottom right, which minimizes the sum of all the numbers along its path. You can only move either down or right at any point. So it's sort of similar to our previous uh, question, whereas over there, what you're doing is for any point, the answer was the sum of the previous point solution, like to the left and to the top, sum of those solutions. Here we don't really have a number of solution kind of a problem, but some sort of different problem where we want the sum of the path to be different. So we'll do the same thing. So since we can only go bottom and right to calculate the sum, what we'll be doing is, again, we can use a 2D matrix or a current and previous array where let's consider the matrix right now, and then you can just convert that to two arrays. Understanding the matrix one is and explaining it is simpler. So for uh, in the matrix, you keep the sum of the minimum sum at that point. So you start from the top left. So you duplicate the first row and the first column to your DP array. And then for starting from the second row and second index, there's 1, 1. You iterate from left to right for all the remaining rows. And you keep the sum as the minimum of the sum of your current number with the number above, and sorry, not dpr is not going to be duplicates of the first row. It's going to be the sums for each index on from that index to its left for the row, and from that index to the top for its column. So for 131 it will be 1 4 5, and for 134, sorry, 114 it will be 1 2 6 in this example. Yeah, so we keep the minimum sum for every point for starting from 1 1. So for say for index 5, we'll have min sum as 5 plus 4 versus 5 plus 2. So we keep 7 at the center index. Then to the right of 1, right of 5 we have 1. For that the sum would be, minimum would be 1 plus 7, that is 8, versus 1 plus 3 4 5, which is 6, so minimally 6. So we keep 6 here. Then for last row we have 2 plus 7 or 2 plus 4 5 6 6. That'll be 8, so we keep 8 here. And for the last one we keep 1 plus 3 4 5 6 6 that was on the top, and 8 here, so that is 7. So the answer would be 7, which is from this path. So again, this is probably like the most straightforward DP question you could ever find. So I'll just copy that. So you have two loops for the row and the column, and then a square loop for the remaining grid. And then you take the last part of your grid. Right. So this is like TP first question you ever do. I mean, one of the first questions you ever do, like the simplest TP question. Okay, I've done this question. I'm not sure if I've successfully done it, which is I've finished it or not. But I have attempted this question, so I remember. I didn't understand what to do in that question, as a matter of fact, at the time. So it says given an absolute path for a file, simplify it, or in other words, convert it to canonical path. One period refers to current directory. Furthermore, double period moves a directory up. Now the return path begins with slash. There must be only a single slash between two directory names. If the last directory name does not exist with a trailing slash, also must be shortest string representing the absolute path. Okay. Basically, all double slashes need to be replaced with a single slash. A double dot means you need to remove the uh, previous non double dots in your list. If there are none, then just count these as counted and keep the list, keep this as empty itself. So A dot B, A means nothing. A single dot means just skip. Double dots mean move back, and another double dot means move back again. Yeah, so that's that. So I think, not sure if I did this last time or not. So simply what you do is you start iterating and keep checking what your current character is. So if it's a slash, just move forward. You don't have to care about those. If it's a string, put it in a stash because that will be the root of your answer right now. If you've not found any strings yet, it doesn't matter. Uh, you look for then you look for dots in a string. If you have a single dot, you just move ahead, and if you have a double dot, you count that double dot and remove whatever's on the top of your stack. Um, that way you'll be going back one step because the latest directory that you get will be on the top of the stack, and when you find a double dot, you will be moving back and removing that from the stack essentially. So you keep doing that till you reach the end of your string, and you will keep your answer will be slash uh, and then starting from the start of your stack basically. So slash starting on the start of your stack, you pop, add a slash to the left, then pop, add that to the left of your answer, then add a slash, keep adding till you reach the stack's end. So again, very straightforward question. So see, get line is probably this is the delimiter. This is your string stream converted into stream. If it is blank or if it's dot, don't do anything. Just skip it, right? If it's a double dot and stack's not empty, then you pop the stack. If it's not a double dot, then you push whatever was written there. And then for each item in your stack, you add slash to it in the start. If it's empty, just return this. Otherwise, return this. Really, really straightforward. The code as well. Now I'm not gonna be stupid and share all these codes with you. Um, over where on Git or something because they're already available on the discussion forum of each question. So no point doing that. Definitely. Um, yeah. So we did submit it, right? Yeah. Cool. This might be taking more time in memory because of this string stream class. There might be other solutions that are faster just iterating. That is, although I don't think you'll find anything except for a good stack solution, except a solution using DQ. Same thing. I don't know why I do that. Also remember to push the stack only in case you find something between two slashes. Right. So I think we did 60 easy questions almost. So we are oh, so yeah, this is our ratio for now. Uh, about 60 easy and 36 hard problems. Let's do four medium problems, sorry, and do let's do four more and see where we at. Given a matrix, if an element is 0, set its entire row and column to 0. Do it in place. Okay, so I've done this also before. There's a very good trick to doing this, which is just goes something like this. So you store, sorry, one sec. Yeah. So you store your first row and first column somewhere, and then you iterate through the remaining array. And as soon as you find a 0 in that array, you set this, like for each row, you set the first you set the first column as 0 and then you break. So you keep doing that. Similarly for each row you do the same thing. And at the end of your iteration, you go through this row and this column. And in case, like if there is a 0 in this column, then you set all these as 0, set all these as 0. Like wherever you find a 0, you set all of them as 0, right? You set all these as 1 when you're copying these values. After you're done doing that, the original first row and first column that you saved, you pick those out and see if they had any zeros. And if the first row had any zeros, set these as 0. And if first column had any zeros, then you set all these as 0. Yeah, so that's how it's done in place. So let me show you. Okay, let's see what this is doing. I find the last row which has 0 and use it to store the 0 columns. Then go row by row to set them to 0. Then go column by column to set them 0. Finally set the last row which has 0 but it's long but here's a 1. Okay, so what he did was find the last row which has 0. So basically it's going to be set as all zeros anyway. So you set it to all zeros. No, you don't. Uh, Last row which is 0 is y. You break, and if last row is minus, and then you exit, which means there's no zeros in any row. Then you go row by row, and is this a 0 row? Basically, if this row is a 0 row, then you set the row that has 0 column to 0. It's kind of confusing. What this did was, if a number is 0, if I is 0, then row is true. Not sure where row and column are used. Okay, later, I guess. Yeah, okay, so if the first row has zeros and the second row has zeros, you're setting the first row and second row as um, yeah, you're setting the values in the first row to zeros for whatever values are zero in the matrix. And then while iterating the remaining array, to the array, you check if the first row or the first column for that index is 0, then you set that value as 0. And then if the first row was 0, the first column was 0, you set all the elements in those as 0. Yes, this is what I talked about. So I think coming up with this solution is not going to be very obvious during an interview. It is sort of a difficult question to come up with, a difficult answer to come up with. I guess you just end up remembering some things that you find interesting. For this one example, I don't remember all these questions for sure. Maybe these just because I did them today, but probably not all the questions that I solved on IB, where I have solved probably somewhere between 4 to 500 questions. That is my guess. Interview bit problems. 300 plus problems. Sorry, so there's 300 total problems. So I probably solved like 150. Yep. Search a 2D matrix. Write an efficient algo that searches for a value in a matrix. The matrix the following properties. Integers are sorted from left to right. The first integer of each row is greater than the last integer of the previous row. So if you had extra space, you would just make a n by m array and then use binary search in it. But what you have to do is write binary search for I and j. Now the relationship that I and j have with I and j have with the index in a 2D array would be that the index here is equivalent to I times m, which is I times number of columns, plus j at any for any index. So you can use that to determine what your high is going to be. So basically, you can keep low as 0, high as m times n, mid becomes high plus low by 2, and then you can calculate your mid I as mid percent m, which will be your which will give you your I plus j, right? Which will give you your j and mid by m, which will give you your I. So sorry, I said it the other way around. Yeah, so mid I will be mid by m and mid j will be mid percent m. So that way you can see if now that index is greater than, and basically binary search appropriately update low and high. You don't really have to keep track of indices anymore in that case. Yeah, so mid by m and mid percent m. So that's the only thing that you need to understand how to solve this question. How, like, what is the value of an index, and how do you relate mid with those indices? So this is just by 2 in a cooler way. Sorry, a break. Lead code, man. Horrible, bro. Horrible. Horrible cases, bro. I hate you. Awesome. fairly straightforward. Sort colors. Not sure I've done this before. Welcome, the one user who is on my stream, I think. Hmm. Okay. Oh, we had some in the past. Yeah. Sort colors. Given an array of n objects colored red, white, and blue, sort them in place so that the object the same color adjacent with with the color in the order red, white, and blue. Here we will use integers 0 and 2 to represent red, white, and blue. Note you're not supposed to use library functions for sorting. Rather straightforward is a two-pass algorithm using counting sort. First iterate. Could you come with a one-pass algo using only constant space? One-pass algo? Damn, dude. It's brutal. Okay, I am thinking of something. So let's say we initialize our array to 0. How do you do it in place? Oh, you do it in place. Okay. Do it in place. In place. In place. And constant space. That's crazy. So I was thinking extra space in single pass by making another array. And when you find a 0, you move your, so you take two pointers, one at the start, one at the end. Whenever you find a 0, you move the first pointer ahead. Whenever you find a 2, you move the last pointer to the left by adding 2 to that index. And whenever, oh no, that won't work either. Damn, that you have to be really clever to know this, to would have to have solved this without looking at the solution. Damn, I'm thinking, okay? Give me some time, I'm thinking. Hmm. So it's got something to do with having only three numbers. So maybe you can do something with not 2 pointers but 3 pointers. So if you find a 1, so if you find a 0, just keep moving. If you find a 1, make it 0. Nope, won't work. That are only setting zeros. Hmm. Okay, so what do we know when iterating? We know that there's either twos or ones or zeros. And in a single pass, we need to, oh, what all can we do is either update a number, say if we, hmm, nahi? Let's keep 2 pointers. If left pointer is smaller than right pointer, we swap. So we have say 2 0, we swap. They move forward. If 2 1, sorry, if we have 1 0, we swap, but we only move the 0. Then we get say 2 1, then we swap the 2 1, then we move the 2, because the 2 is in the right place, the 1 might not be. Got it. Take 2 pointers, int left is 0 and right is nums dot size minus 1, while left is less than right. That's one pass, right? Um, if nums left what if they're the same? Okay, let's focus on that later. Nums left is greater than nums right. Swap nums left nums right. So left was greater if nums left is equals 0 left plus plus if nums right equals to right minus minus. Else if this was less than right, then don't do anything. Else now say if we find 0 and 1 or 1 and 2, that's handled. If you find 0 and 2, that's handled. But if you find 1 and 1, we're not moving anywhere. So if we have 1 and 1 at the border, we're screwed. Hmm? See, it's 2 0 right now. Now it becomes 0 2. Now it's 0 2. Now it's 1 2. Now since it becomes 1 1, that's when you get screwed. So you find both ones. Cam, I am very sure that the algorithm is something very close to this. But if we find 1 and 1, and then say we have 2 0 1 2 2 inside, how do we swap? So either we find the next 0 for the left one, or we find the next 2 for the right one, and then we swap those two. If nums left equals 1. So if they're both same, okay. If they're both 1, int k equals left plus 1 while k is less than right and k nums k not equal to 0 k plus plus if k is greater than right, so you didn't find any zeros. If k is less than right, swap nums left, nums k, left plus plus, int L equals right minus 1, while L is greater than left, and nums L not equal to 2, L minus minus, if L is greater than left, swap nums L and nums right, right minus minus. So if either of them or both of them happen, great. If L is less than equal to left, less than equal to left, and R is greater than K is greater than equal to right, so they're all ones. Break, return, run code. This should work. Brilliant, boys. Almost perfect. Okay, so let's see where this broke, because it shouldn't have according to my logic. So for 0, 1, 0, if nums left is greater than nums right, if they're same, if left is 0, left plus plus. We move on, left becomes 1, left becomes 1. If nums left, nope. If nums left is greater than nums right, yep. We swap them. Yeah, and then left plus plus, and then left should be equal to right. Nums left is 0. Sorry. Yes. No. If it's 1, left, 2. Huh? Oh, my bad. So we break in this case, right? Yeah, forgot that. Don't I need to, but sorry, not break, it's more of continue. Or you can just add else if, that is. Perfect. Absolutely perfect. I feel like, okay, this probably has our solution as well. Two pass, one pass in place. So they say if it's 0, there's two iterators. Looks very weird. If it is, put them all to 0. If it's 0, then make it 2. Then make it 1, then make it 0. If it's 1, then make it 2 and then make it 1. I don't even understand what this is. If it's a, if it's a 2, then it's 2, then A0 is 2. If you find a 1, you move forward your last 2 to here and set your previous 1 to 1. If you find another 1, say, then you move your last 2 and add 1 in its place. Move your first 2, last 2. So say if you have another 2, then put it as 2, 2, 2. Oh, you're overwriting after the last one, and damn, that is clever. I would not have thought of that. Okay, quite a few solutions. You can go through them. This is what I got in my head, so I did it this way. Combinations. Given two integers, return all possible combinations of k numbers out of 1 to n. That seems like very straightforward backtracking. So using the for loop method that we're trying to learn these days, we can just call our helper with our target being k and reducing our target every time. So is 1, 2 and 2, 1 different? No, good. So a for loop from 1 to n, from for loop from 1 to n while size of set is less than k, uh, and then in our calling our helper function from that loop while pushing and popping out each element once, um, and also removing it from our set. Is that true? No, we just need to change the beginning. So instead of from 1 to n, it goes from beginning to n, and the next new beginning is I plus 1. Um, And as soon as the size of the set is k, we can just return. So a while loop with our what? Okay, my brain is being blown. While I is greater than equal to 0, it's just one loop. If pi is greater than n, then I minus minus. If pi is greater than n, if pi is greater than n, I minus minus. Okay. If I is k minus 1, then push back the result. Else I plus plus and pi is last number only. And then pi plus plus. So we have 1, then we have 1, 2. So that gets pushed. We have 3. I becomes 3 if it's greater than n. No. Then you go in here. Then P3 becomes P2, which is P3 becomes P2. So they're both 1 and then they're both 2. It's not making any sense to me. It's very confusing. Yeet. Okay, nobody seems to be doing it the way I did it. Yeah, this is what I was talking about. This is start. You send I plus 1 every time. Um, then if the what is num is probably the length. Uh, 0. Yeah, num's the length. When length is target, then you add it to list. This is what I was talking about. I'm just gonna write this down. Now let's take care of the stupid cases where he has taken care of one. See if there's more. Not like, not other stupid cases where n is empty or m, I don't know, some other stupid things. Anyway, okay, so we finally solved 100 questions. Oh, this is 45 medium and 55 easy. That's nice. That's a good stat. So it's already been a almost a 3 hour session. Let's just say 2.5 conservatively. Um, yep. Oh, why is it not showing my solved problems? Oh yeah, solved problems somewhere in your profile. Hmm, solved problems, yeah. So I have done 152 questions. Yeah. Oh, okay. Many of which are duplicates on this. I would say at least, let's say half, if not all duplicates, then half of them are duplicates plus similar questions or very easy questions that are too easy. Okay, so yeah, as I was saying, 100 questions. I think 60 of them, 55 of them were easy, and 45 were hard. Sorry, medium. We'll stop here. I'll make some changes to the channel, uh, like adding a banner when I'm off, and I'm not sure if I'm gonna get a webcam super soon, but it'll be soon for sure. So yeah, you guys gonna see my face soon, yeah? Right, so all the best. Oh yeah, important news before I forget. I will not be streaming tomorrow. I'm going out in the evening, so I won't be streaming tomorrow. Um, I might if I come back home late in the night, I might come back after 12 or something. Not very sure. Might again. So yeah, then I might stream then. So until then, adios and keep practicing. All right, bye bye.